Before an electronic ceramic becomes dense, it must shrink while resting on a surface that does not sag, react, or imprint the body. A zirconia setter plate is kiln furniture. It carries and positions parts during firing while the supported ceramic changes dimensions. Its real function is not merely to survive heat, but to preserve the firing geometry. This kind of refractory plates can be formed as several setter formats, such as thin flat plates, a thicker plate, and a shallow rim tray. These forms are not interchangeable by appearance alone. Flat setters maximize open loading area, raised rims help contain parts or powder, and rails or grooves can reduce contact area or open a gas path. The form follows the load and furnace arrangement. Refractory zirconia is not the same material design as dense structural 3YTZP. Calcia or yttria is used to stabilize zirconia phases for prolonged high-temperature service. This plate family is specified for continuous operation up to 1600 degrees Celsius, but the usable limit still depends on stabilizer chemistry, atmosphere, load, porosity, and the complete heating and cooling cycle. A refractory setter is intentionally porous rather than fully dense. Independent zirconia setter data reports about 25 to 27% apparent porosity, density around 4.1 to 4.2 grams per cubic centimeter, and cold modulus of rupture from 16.5 to 33 megapascals. The contact surface must remain chemically compatible with the part being fired. Zirconia setters are used for barium titanate capacitors, thermistors, piezoelectric ceramics, ferrites, and other electronic ceramics because stabilized zirconia can provide a non-reactive support in selected oxide systems. Compatibility is never universal. Fluxes, vapors, dopants, atmosphere, and dwell time must be reviewed together. Under load, a setter behaves like a ceramic beam. Bending stress rises when the unsupported span grows or when parts create concentrated point loads. Furnace supports should therefore be level, symmetrically placed, and aligned with the plate geometry. A thicker plate can increase load capacity, but it also adds thermal mass and can increase temperature lag through the section. Zirconia has low thermal conductivity, so the two faces of a plate do not instantly reach the same temperature. Fast ramps, uneven furnace exposure, or a cold support can create through thickness gradients and tensile stress. Thickness, porosity, heating rate, cooling rate, and support contact must be treated as one thermal design rather than as separate purchasing dimensions. The setter surface controls more than support. A smoother face can reduce imprinting and friction as the green body shrinks. A rough or porous face can increase atmosphere access or retain sacrificial powder. Rails and grooves reduce the true contact area and create flow paths, but they also change local stiffness. The firing process decides which contact design is appropriate. For this plate family, common flat formats run from 75 by 75 to 150 by 150 mm, with thicknesses roughly 3.5 to 5.5 mm. Round formats of 95 and 115 mm also appear, while slotted plates add raised features from about 4.5 to 13 mm. Industry offerings also include discs and two rail setter plates. A custom drawing should define length, width or diameter, thickness, flatness requirement, edge radii, rim or rail height, slot geometry, support points, loading map, and allowable contact area. Material grade and porosity must be linked to the actual atmosphere and firing cycle. Overspecifying every surface adds cost. Underdefining the support geometry creates process risk. During barium titanate capacitor firing, green ceramic pieces shrink and densify above 1300 degrees Celsius. The setter provides a stable reference plane so arrays remain supported while binder removal, sintering shrinkage, and grain development change the body. The firing interface must not introduce a reaction layer or loose debris into the dielectric ceramic. Stabilized zirconia is selected when chemical compatibility with the oxide system is more important than using the lowest cost kiln furniture. Porosity, rails, and loading gaps allow the furnace atmosphere to reach the parts while limiting contact. At peak temperature, the plate is no longer a tray. It is the temporary reference surface that the entire sintering geometry depends on.